Okay, so today I'm going to go through how to do the chemistry exam revision for semester 2. It's year 10. It's going to cover these Victorian curriculum outlines, particularly the semester 2 revision ones for our exam, remembering of course that all of this can be examinable or is considered prior knowledge. Okay, task 1 was to annotate the periodic table. Now we've done it a few times this year. This is a revision for you, and you will be given a periodic table on the exam. But things that you need to be aware of, make sure that you label the groups across the top and that's how they behave. The number of shells go down. So for example, francium here has got 7 shells, electron shells, with 1 electron in its outer shell. Silicon over here, which is a metalloid, has got 3 electron shells with 4 outer shell electrons, all called valence electrons. The other thing I've done on my paper is I've just annotated it a little bit to again show what we can find from there. So if we look at chlorine as an example, it has an atomic number of 17, you've got your chemical symbol, and you have got the atomic mass of 35.4527. From that we know that there are 17 electrons, 17 protons in the atom, not in the ion, and that there are 18 neutrons present. How you label your periodic table and whether you choose to take a labelled one in as part of your cheat sheet is up to you. I personally think that taking one in is a waste of time. Maybe just do a quick sketch at the top of one of your revision sheets, remembering that you can have a double-sided A4 sheet saying what the groups are, what the periods are. Okay, so task 2 was using the periodic table and ion table from the previous page. Complete the compounds. So for the first part you are writing the name of the ionic compounds. Now things that are assumed knowledge here is that you know what an ionic compound is. So an ionic compound is typically made up of a metal, or it is made up of a metal and a non-metal, and involves the giving and taking of electrons, outer shell electrons. Quite often our more common metals will not be on the ionic table. Sometimes they are, sometimes they aren't. That's why you need to understand how the periodic table works in terms of magnesium. So if we look at the first one there, we've got magnesium as our first one. Magnesium is in group 2, which means it's going to have a charge of 2 positive because it is a metal and gets rid of its electrons. So the other thing we need to remember about ionic compounds is that they have a net overall or net charge of 0. So the ion charges must balance out. So looking at this one, we've got Mg, which means magnesium, as I just said. And then remembering that capitals signify a new element is present. So we've got magnesium, and then we've got this polyatomic ion with sulfur and oxygen in it. So we're going to need our ion table for that. We go through and we find the one that has sulfur and oxygen. We need to make sure that it has the same number of oxygens that are present in the list. So in this instance there's 4 oxygens. Here has 4 oxygens on the sheet. Okay, so it is magnesium sulfate. For the next one, calcium, and it only has 1 element present, so we're going to use our periodic table for that, and it's going to be calcium iodine. Remembering that the halogens change from ine to diide. Okay. Next one, lead for Pb. So again we find lead on our periodic table, and then we look for our polyatomic ion here in our list. And again, it's going to come down to dichromate. Okay, so it's lead dichromate. Last one, again, sodium is your metal. The OH means that there are 2 present there, so we need to use our ion table, and it's going to be hydroxide, so it's going to be sodium hydroxide. Okay, for the next part, it says we need to write a balanced equation. That means we need to get the charges so that they equal 0. So if we have a look at the example given, we've got sodium plus oxygen to make sodium oxide. You've got 2 sodiums because oxygen has a 2 negative while sodium has a 1 positive. So again, we go through, we've already got oxygen here, so we know it's going to be 2 negative. We've got magnesium from group 2, which means it's going to be 2 positive because it's in group 2 and gets rid of 2 electrons, which makes magnesium oxide, and there's only 1 of each. Calcium is in group 2. Again, you can check this yourself. Chloride, and we've got the "-ide" there to indicate that it is existing in ion form, is -1, which means we need 2 of them to balance out the calcium, so we end up with calcium chloride. This funny number here indicates what charge the tin has. It's a Roman numeral for 4, so this is tin, 4 positive, plus sulfate. So it's not a single element because it's not sulfur, it's sulfate, which means it's going to be the 4 negative. Now, 4 positive, 2 negative means we need 2 of those to balance it out. So 2 times -2 is -4. That balances out. Now, when we write them, because we've got 2 molecules of this sulfur and oxygen molecule, so the sulfate molecule, we have to put it in a bracket and write it as it is, and then how many we have down the bottom. Again, we've got iron 3, so it's 3 positive, plus sulfur 2 negative. We need to find the lowest common multiple of these 2 numbers. So 3 goes into 6, 2 goes into 6. So to make that 6, we're going to have to multiply it by 2. To make that 6, we're going to have to multiply it by 3. We write it as iron 2 bracket sulfate 3. Okay, so for the last part of this one, we've given the names of the compounds and we have to write the balanced ionic equation. Now, if you need to, you can do the equations like we've done before. Otherwise, maybe put a hint to yourself. Beryllium is going to be in group 2. So it's 2 positive. Sulfide. So this is sulfide, so it's going to be just sulfur. Sulfur is also 2 negative, so we have beryllium sulfide. We've got potassium 1, chloride 1. And you'll notice that we don't put the numbers in when we've got negatives. So it's going to be potassium chloride. Remember the lowercase. Iron 2, hydroxide is -1. So it's going to be Fe bracket OH2. Aluminium is 3 positive. It gets rid of 3 electrons. Sulfate is 2 negative. Again, we find our lowest common multiple, which is going to be 6, so it's going to be aluminium 2 bracket sulfate 3. And the last one is lead 4 and phosphate, which is 4 and 3 negative. Lowest common multiple is going to be 12. To do that, we need 3 of those and we need 4 of those, so it becomes PB3 bracket PO4 close brackets with a 4 on the outside.